Okay, so now let's really quickly hit multiplicities of the real zeros of a polynomial function. So we just got done talking about real zeros, right? Now we're going to have these things called multiplicities, and multiplicities sound complicated. They're actually really straightforward. It's directly tied to the exponent of that particular factor. So remember, we talked about if x minus a is a factor of a polynomial f. So now imagine that you've got x minus a, like let's say an x minus 2, but that x minus 2 is raised to the second power. Okay, so then a is called a zero of multiplicity n, right? So the exponent itself serves as, that tells you what the multiplicity is. Okay, so let's take a look at an example. In this one, they just want us to find the zeros, state their multiplicities of the polynomial function. So it's already broken down into factors, right? The hard part's already done for us. So we're going to set all these equal to 0, just like we always would have. And hopefully what you're seeing is the relationship between the factors and the zeros without having to go through this step. So this would end up being x is equal to 1, x equals negative 3/5, pardon me, and x equals negative 5. All right, now here's the thing though. With this factor of x minus 1, it was raised to an exponent of 2. So behind my x minus 1, I would put multiplicity of 2. Behind the x equals negative 3/5, I'm going to put that this is a multiplicity of 7. And behind this one, I don't have an exponent, so I don't have to put anything here. Its multiplicity is 1. Right? So it's just a single root. And so we don't have to, if the multiplicity is 1, we don't necessarily have to note that again, like a phantom 1 kind of situation. The 1's always there, you just can't always see it. All right, so that's the idea behind multiplicities. All right, now, relating to multiplicities, there's something you need to know about that. If the multiplicity is even, this actually is going to have an impact on the graph. So if the multiplicity of something is even, and we're not going to do a lot with graphing today, but we wanted you to know where this is coming from and what it's going to look like as we move on through this, then what's going to happen is it touches the x-axis or turns around at that particular root value. So for instance, if negative 2 is one of your roots and it has a multiplicity of 2, then that means this thing is going to bounce off of the x-axis. It is not going to intersect it. It's not going to cross it or go through. It's going to bounce. Okay, so that's actually my preferred terminology, is I'm going to say this, that the graph is going to bounce off of the x-axis. Now, if it is an odd multiplicity, then that means it is going to cross the x-axis. So let's say at positive 3, maybe we have an odd multiplicity, and 1, by the way, is odd. So if you have a multiplicity of 1, that is odd. So it's going to cross through. So you might have something that looks like this, where it actually crosses through that particular x-axis. Okay, so remember, even multiplicity bounces, odd multiplicity crosses and goes on through the x-axis. All right, now what I'd like for you guys to do is pause this video and figure this one out. We want you to find the zeros of the polynomial function, and this should say and find its multiplicities. Here's the other thing I want you to do. I want you to tell me in your answer, does this thing bounce or cross the x-axis at each one? You don't have to draw it, but I just want you to tell me what it does, because you can tell directly from its multiplicity. Okay, so please pause the video and work this out now. Okay, welcome back. Hopefully you had a chance to get this worked out. This is what my answer looks like for this problem. So this one, I took that shortcut, right? Because I understand that relationship between the factor and the root, or the zero, or the solution. So I knew that if I set this one equal to 0, then my root is 0, right? So, and because of my exponent of 2, it has a multiplicity of 2. Because that's an even multiplicity, I know that my graph is going to bounce off of the x-axis at that particular root okay, of the function. So then in this next one, x minus 2, well, since I have a factor of x minus 2, I know that positive 2 is going to be where it crosses the x-axis. My exponent says I have a multiplicity of 3. Because that multiplicity is odd, I know that my graph is going to cross through the x-axis at that particular root value. And then the next one, similar type of thought process here. Because I have x plus 1/2 in the factor, I know that the root is going to be negative 1/2. My exponent tells me I have a multiplicity of 5. Because that multiplicity is odd, I know that my polynomial, the graph of the function, is going to cross the x-axis at that particular value. Okay, so that's really all there is to those. All right, now we're going to switch this around just a little bit, and what we're going to ask, or what they're asking us to do, is to find a polynomial of degree 7. So they're telling us the degree whose zeros are, and then they've got those listed down here for us. Okay, so if we have a root value of negative 2, that means that is going to relate to a factor of x plus 2. Okay, so we're just going backwards now. Instead of going from a factor to a root, we're going from the root value to the factor. So again, we're going to have to change that sign that's on this, right, and make that an x plus 2 within our factor. It's a multiplicity of 2. That means my exponent is going to be a 2. Now, when we have a root value of 0, you can write this as x minus 0 if you'd like, but in essence, that's just going to be an x, and that has a multiplicity of 4. And then a positive 1, so my factor is going to be an x minus 1, multiplicity of 1. So you can put the exponent there, but of course we typically don't even see that. So let's call this an h function, h of x. Why did I choose h? I don't know, I just did. There's no magic to that. Okay, now what we're going to do is multiply these things out. So, and we don't always make you guys multiply them out, but for the purposes of this video, I think I'm going to do that. So I'm going to rewrite this as x to the 4th times x plus 2 quantity squared times x minus 1. X to the 4th, of course, is going to be distributed in last. That'll be the last thing that we do. So I think I'm going to do a little side work here. So x plus 2 quantity squared, nah, not yet. I can go ahead and work that out. Remember, that's x plus 2 times x plus 2. So this is going to end up being x squared plus 4x plus 4. If you need to take a minute and FOIL that out, go ahead. And then I still have that being multiplied by x minus 1. Okay? Now, I'm going to distribute my x minus 1 through this set of parentheses, okay? And the way that we want to do that, so if I take x minus 1 times x squared plus 4x plus 4, this is when you use the distributive property, that means we're just going to take each piece at a time. So first my x, and distribute it through that set of parentheses. And then I'm going to take this minus 1 piece and distribute that through my set of parentheses. Okay, distributive property is pretty handy. So now we're going to go through and multiply this through. If you ever need to pause the video and catch up with me, feel free. Now I'm going to distribute my negative 1. And now I'm going to combine like terms. And you'll see here that my 4x's cancel. And I've got a minus 4 there. Okay, so this turns into x to the 4th times x cubed plus 3x squared minus 4. And then I just distribute through my x to the 4th. So that's going to give me an x to the 7th power. Remember, when you multiply base to a power times base to a power, you add those exponents together. Plus 3x to the 6th minus 4x to the 4th. So this is my polynomial. Whoops, got an extra parenthesis there. All right. So there you go. That's my 7th degree polynomial. All right, now please pause the video and try and work this one out just like we did on the last screen. Okay, welcome back, guys. So first off, I want to apologize because if you were paying attention to the directions up here, it said to find one with a degree of 7. Turns out that was a degree of 6, and I had just copied that from the previous slide. So my apologies if that threw anybody threw a wrench in the works. So anyway, what you end up with is what we have here on the screen. It is a 6th degree polynomial. All of that side work with multiplying this piece out is over here to the right in blue. There you go. You can check your work. And if you have any answers on that, please, or have any questions on that, pardon me, please jot those questions down and bring them to class and ask Mr. Sickmiller or myself. So that wraps it up for this slide. That takes care of it. So hopefully this helps you complete those target problems. And if you have any questions, like I said, bring them to us and let us know. Thanks a bunch for watching. Bye-bye.